What is photoelectric effect? What is photoelectric effect? And what are the experiments for this? For this, Hallwich and Leonard performed one experiment. That one experiment was that what they find that they took one glass tube, this is a commutator key, this is the rheostat, this is the battery, positive terminal, negative terminal, this is anode, O plate, it is cathode, this cathode, initially anode. This commutator key is being used to switch over the potential given to anode and cathode. Initially anode is given very high positive potential and cathode is given the negative potential. Now look what happened, that initially from this window the ultraviolet radiations are being incident onto the surface of the anode. When this this is a cathode and this is anode. When these ultraviolet radiations are being incident onto these tungsten, zinc, aluminum made cathode, then what will happen? The electron starts to emit from the surface, and this electron given to the due to the given high positive potential to the anode starts to move toward the anode, starts to move towards the anode. Now here in this case they use ultraviolet radiations for the emission of electrons from the surface of the cathode, and they came to the new emission, find that whenever a surface is being incident by the high energetic electric beams, for light beams, then electrons are being started to emit from the surface. But later on they replace this cathode of zinc, aluminum, tungsten with the alkali metal coated cathodes of metal oxides coated cathodes. When metal oxide coated cathodes are being used there, what will happen when the incident radiations are used of a visible spectrum? Alkali oxide coated cathode surface is being used, and when the incident radiations are visible light, incident radiations of visible spectrum, then emission of electron takes place from the surface of the cathode. Emission of electrons takes place from surface of cathode. So So they did this experiment with the two different radiations. Initially they performed the experiment with the ultraviolet radiations for the general metals, but later on and they converted it into the alkaline oxide coated cathodes and incident radiations of visible spectrum, and they get the emission. So this phenomenon is called as photoelectric emission. Emission of electron from the surface of a cathode when incident light radiations are being incident on them is called as photoelectric emission. Is called as photoelectric emission. Is called as photoelectric emission. Whenever the surface of a cathode is being exposed to the light, then electrons are being emitted from the surface of the cathode. That phenomenon is called as photoelectric emission. That phenomenon is called as photoelectric emission. That phenomenon is called as photoelectric emission. Got it? Draw the circuit diagram. Draw the circuit diagram. Okay. Okay. We'll now write the definition and we'll go further right now. So what will be the definition of the photoelectric effect? The definition for the photoelectric effect is emission of electrons from the surface of cathode when light energy is incident on it is called the photoelectric emission. The emitted electrons are called as photons. Are called as photons. Are called as photons. Now here one thing that we have to study is that what is this effect and what is the previous effect of this type. We have one also effect that is called as thermionic effect. Thermionic emission. We must have to understood this also, because this is also the part of the NEET. Here when surface of cathode is heated, then electrons are emitted. Emitted from it is called as thermionic emission. And emitted electrons here and emitted electrons are called as thermions. Emitted electrons are called as thermions. Emitted electrons are called as thermions. Now in these two concepts we must have to study the concept of binding energy. The concept of binding energy. We know that if we consider an atom, this is the central core, that is called the nucleus. This is the first orbit. This is the second orbit. This is the third orbit. So on so forth. Now when we consider this is the atomic structure, then these electrons in the first orbit, second orbit or third orbit or any orbit are being binded to the nucleus, which is a positively charged, with the help of electrostatic force of attraction. With the help of electrostatic force of attraction, they are being binded, they are being attracted to the center. So now if I want to remove this electron from the influence of the nucleus, then I have to give it the energy equivalent to the binding energy in the opposite direction. So here in these two cases, in the one case we are giving the energy to the atom greater than the binding energy in the form of light energy, that is called as photoelectric effect. Or here in this thermionic emission we are giving the energy to the electron greater than the binding energy in the form of heat, and that is called the thermionic emission, and the emitted electrons are called the thermions. So this is the basic concept of these two, that an atom has positive and negative charges. The electrons which are moving in the outer orbits, they are being binded with the electrostatic force of attraction to the nucleus. If we want to make them to remove, we have to give the energy greater than the binding energy, and that energy with which they are being binded, here they are called as the binding energy. So we have to give them energy in the opposite direction, because electron is being attracted inside, we have to get in the opposite direction. That is called as this one. Now write down the definitions. Next one. Now we have to experimentally study the photoelectric effect and its characteristics. Characteristics of the photoelectric effect. To study this, we use photocell. What is a photocell? To study this, we have to use the photocell. Photocell is an electrical device which consists of this a circular, semicircular cathode, and at the center of curvature of this circular we are keeping one anode, and this is a crystal glass, It is a cathode K, it is anode A, or sometimes it is also called the plate. This cathode is a circular in shape, and this surface of this cathode is being coated with oxides. Metal oxides, and it is made up of tungsten. And this is crystal glass coating, crystal glass cover, and these are the two leads which are being taken out for the connection there. Now in this form, curved form, the cathode is being there, and at the center of curvature of this anode is being kept. What is the advantage of curved nature? The advantage of this curved nature is that, and this is the anode, this is the symbol, and this is the symbol. Now this is anode and this is cathode, and these are the radiations which are being incident onto the surface of cathode. Now this is the curved nature of this one, and this is at the center of the curvature the anode is being kept there. What is the advantage of this curved nature? The advantage of the curved nature is that larger surface area is being compacted into the smaller volume. Second thing, all the electrons which are being emitted from the surface of this cathode will be automatically directed towards the anode. Third thing, all the electrons emitted will have to travel the equal distance. This is the advantage of this one. This is the symbol for this photocell. Now we have to use this, and we will be studying the characteristics of the photoelectric effect with this help of this one. I am drawing the circuit diagram using the here also we will be using the commutator key. We are also using the commutator key here. This is the anode. First anode will be connected to the positive terminal of the battery, positive, negative. This is the rheostat. With the help of the potential given to this will be changed, and this is this K A upload, and this is the incident radiations. This is the milliampere meter. Milliampere meter will give us the current flowing through the anode. When the electrons are emitted from the surface of the cathode, they will be moving to the anode and they will be traveling through this, and this milliampere meter will give us the current flowing through this. We give us the current flowing through this one. Now this is the circuit diagram to study the characteristics of the photo cell. Draw the circuit diagram right now. So I will give some time to you. This is the photo cell, symbol for the photo cell, the circuit diagram for this one. Okay. Now here we have to study the parameters which affects the photoelectric current. First one is the parameters which are here. We have to study frequency or wavelength of incident radiations. Second parameter that affects the photoelectric current is intensity of incident radiations. Intensity of incident radiations. Third characteristics, the anode potential. These are the three parameters which affects the photoelectric current. Now, when we study the characteristics, we have to study any one of the factors. So initially, we will be keeping the intensity of the incident radiations constant, and anode potential is at high positive potential. So, and we will be changing the variation of frequency. तो अब अपन here we will be studying the effect of frequency on photoelectric effect. Now here in this case the other two parameters, that is intensity of radiations, intensity of light radiations is constant, and anode is kept at high positive potential. These are the two variables which are being kept constant. Now we start incident some radiations initially. Let us consider at a low frequency we started to incident the incident radiations. When we incident low frequency radiations, then no photoelectric emission will be taking place. Here, if we continue to go on increasing the frequency of the incident radiation slowly, at one frequency, the emission of electron from the surface of the cathode starts to take place. Now look here, at a certain frequency, the emission of electron starts to take place. And if we continue to go on increasing the frequency, the emission will be continued. But at a low frequency, the emission was not being there. So as we know that according to the Planck's quantum theory, E energy is proportional to frequency, or E is equal to h nu. So as we continue to go on increasing the frequency, what we are doing? We are increasing the frequency, we are increasing the energy of the incident radiation. As we going or increasing the frequency, we are increasing the energy of the incident radiations. At a certain frequency, what will be happening? The emission of electron takes place. And what was that point? At that point, the energy of the incident radiations is equal to binding energy of the electron. At that point only, the emission takes place. Again I am telling you, at low frequency, the emission of electron does not take place. But if we continue to go on increasing the frequency, what we are doing? We are increasing the energy. So at a certain frequency, then emission of electron starts to take place. When emission of electron starts to take place, at that point, the binding energy of the surface of the cathode is equal to the energy of the incident radiation. At that point only, the electron emission will take place. At that point only, the electron emission will take place. And that frequency at which the emission of electron takes place is called as threshold frequency. Is called as threshold frequency. Threshold frequency, and it is being shown by the nu zero. It is being shown by the nu zero. What is the threshold frequency definition? The minimum frequency of the incident radiations at which emission of electron, emission of photons from the surface of cathode, just starts is called as threshold frequency. Is called as threshold frequency. Now what are the characteristics of this threshold frequency? Below threshold frequency, no electron emission, no photon emission. Second one, above threshold frequency, electron emission or photon emission will continue. Photon emission continue. Third one, at threshold frequency, the binding energy of cathode surface is equal to energy of incident radiations. Energy of incident radiations. Now these are the characteristics of the fourth important characteristics that we have to study is that the threshold frequency gives constant emission of photons. So current does not change above threshold frequency. This is very important because threshold frequency just defines whether the electron will emit or not. But once the emission takes place, the number of electrons emitted above threshold frequency will be constant. That means here below threshold frequency no emission, at threshold frequency 100 electrons are being emitted. So if you continue to go on increasing the frequency above threshold frequency, the number of 100 electrons will be there only. But what will be changing there? The energy of the electron will be changing. As we increase the frequency, the electron energy will be larger and larger one. And the next one is above threshold frequency. Electron energy increases. Now look here, these are the two very important points. Value of current doesn't change because the value of current depends upon the number of electrons emitted. Frequency does not change the number of electrons. And another thing that frequency changes energy, so the emitted electrons will have the higher and higher energy. So this is the points which we have to study about the threshold frequency. Now, as we know that when a light wave is being there is associated wavelength with the frequency. So the associated wavelength with the frequency is called as threshold wavelength. The wavelength associated with the threshold frequency is called the threshold wavelength. Got it? Okay, write down it.